Welcome to the end of the series we initiated at the beginning of this week. We had a series for the solution of the practice questions for Math 304, which is differential equation at the University of Liberia. My name is Clinton P. Kui, presenting on this episode. And today we want to quickly look at question number 17. But if you haven't seen the list of questions from 1 to 16, I will encourage you to check it out on our YouTube channel. So let's quickly move on to question number 17. What is the equation of the curve satisfying the differential equations y prime prime, parenthesis open, x squared plus 1, it closes, equals 2x y prime, passing through the points 0, 1, and having slope of tangent at x equals 0 at 6. Now let's explain what this means. We want to find the equation of a curve. So we have something like this. So let's give you a pictorial understanding of what this is. So we have the curve like this. We want to find the equation of this curve that satisfies this differential equation. So the curve, whatever curve, satisfies this differential equation. And this curve passes through the point 0, 1. So what is 0, 1? X is 0, y is 1. So the curve passes through this point. And the curve is having slope of tangent. So if you draw a tangent line to this curve, the slope of this tangent line at x equals 0 at this particular point is 6. So what is the equation of that curve? So this is just a pictorial, representation of what the question is about. So let's quickly move on to find the solution. So the first thing we do is to begin with the differential equation y prime prime, parenthesis open, x squared plus 1 closes, equals 2x y prime. And once we've done this, we can separate variables. To separate variables means to bring all of the x on one side and bring all of the y on the other side. So we have, we do not want this here, so we divide each term. So let me just rewrite this. X squared plus 1 equals 2x y prime. So I'll divide this out because I do not want y prime here. I divide this out by y prime. I divide this out by y prime. This is y prime prime. And then I do not want this here, so I divide this out by x squared plus 1 and divide this out by x squared plus 1. So what do I have? Then these are going to cancel out. I'm going to have y prime prime over y prime is equals to 2x over x squared plus 1. Because these are going to cancel out, and also y prime are also going to cancel out from that equation. And once we've done that, the next thing we could possibly do is to integrate both sides. But before integrating both sides, we realize that this is the derivative y prime, and the derivative of y prime is y prime prime. So we integrate, we have the integral of y prime prime over y prime. Remember, we are integrating this with respect to y is equals to the integral of this now is 2x over x squared plus 1. And we are integrating this with respect to x, so it's dx. So it's y prime prime over y prime dy equals the integral of 2x over x squared plus 1 dx. So once we've done this, the next thing to do is to realize that this is derivative of a function. So we differentiate y prime, we get y prime prime. So this is the ln of y prime. So the ln of y prime is equals to, this will give us, if we differentiate x squared plus 1, we have 2x dx. So this is going to give us the ln of x squared plus 1 and then plus a constant c. So that constant, I can rewrite that constant as the ln of c. Because c is the same as ln of c, because ln of constant is just a constant. So we have the ln of y prime is equals to, using the property that says that you have the ln of a plus the ln of b, you can take ln of ab. So you can take the ln of c times x squared plus 1. And once we've done that, we can try to get rid of the ln by taking the natural log on both sides. So we take the natural log on both sides, and let's see what we have. We have e raised to the power of the ln of y prime is equal to e raised to the power of the ln of c times x squared plus 1. So e raised to the ln of anything is just that thing. So y prime is equal to c times x squared plus 1. Now, this is the derivative y prime, and this is what is equal to. So this is the derivative of the function. But we are told that the slope of the tangent line, which is the derivative of the function at x equals 0 is 6. So the slope of the tangent line at x equals 0 is 6. So what we'll do, replace y prime with 6 and replace x with 0 from where we have there. So replace y prime with 6. So we have 6 is equals to c times 0 squared plus 1. If we do that, we have 6 is equals to c multiplied by 0 plus 1. So 6 equals c, which means c is equals to 6. Great. So we can write back again and write y prime is equal to 6 times x squared plus 1. Because we have c equals 6. That's right there. Now, once we've completed that, the next thing to do is to multiply each term in there by 6. So go and do the multiplication. We have y prime is equals to 6 times x squared is 6x squared. 6 times 1 is 6. Good. What is y prime? Y prime is dy by dx. So dy by dx is equals to 6x squared plus 6. We can separate variables. Dy multiplied by dx by dx is equals to 6x squared plus 6 dx. Great. Once we do that, we can now move on to integrate both sides. But we have to do the integration on this side of the equation. So let's quickly move on to do that. So I'm going to erase this out. And then we are going to do the integration right here. So here we have dy by dx is equal to 6x is equal to 6x squared plus 6 dx. We can integrate this out. Integrate this out. The integral of dy is just y. So you have y is equal to the integral of 6x squared. You know, you add 1 to the power and divide everything by 3. So that's 3x cubed. Oh, sorry. Integral of 6x squared, yeah, is 2x cubed. 2x cubed. Because we are dividing, adding 1 to this power and dividing by 3. 6 divided by 3 is 2. So it's 2x cubed plus the integral of 6 is just 6x. 6x plus some arbitrary constant c. Great. But we know that the curve, which is this final result we are getting, passes through the point 0, 1. So when x is 0, y is 1. So 1 is equal to 2 times 0 cubed plus 6 times 0 plus c. So 1 is equal to 0 plus 0 plus c. So 1 is equal to c, which means c is equal to 1. In the second constant, we have c. Remember, if you have second order differential equation, you must have two constants. So we have c right there. And the final equation for this question, which is the curve that the question is asking for, is y is equals to. So this now is the curve that the question is currently asking for. I'm just going to write that in red. Y is equals to 2x cubed plus 6x plus c. Well, no, c is equal to 1, so plus 1. This, ladies and gentlemen, is the equation of the curve in question. Thank you very much for watching, and we hope you subscribe to our channel for more amazing videos. Bye.